Hi guys, this is going to be 12.3 experimental probability of compound events. So we're going to start with notes. 12.3 experimental probability of compound events. Okay. So a compound event is when more than one thing is happening at the same time. So compound event, more than one thing is happening at the same time. So we can have a couple of different things going on. We could be sitting here and saying, I want to order a sandwich and I can get ham, chicken, or beef, and I can get cheddar, mozzarella, or provolone. And then how many different types of sandwiches can I get? However, for this particular one, we're talking about how likely it is that something is going to happen. And so what they have us working with is flipping a coin or rolling a die. It actually has us working with both of them. If we look into it, we have to come up with more. So depending on how many possible options you have, you can end up with a ton more than you think that you should have just by using your two possibilities that you already have. So when we look at this, we are looking at the possible. I'm looking at A at the moment. I'm on page 381. On A, it says, what is the possible outcomes of flipping a coin once? So you have either heads or tails. So heads or tails. B, what are the possible outcomes of rolling a die? A standard number cube. They mean die once. So that would be 1, 2, 3, 4, 5, 6. Those would be our options. Letter C is every single possibility that we could have. So this is how this works. It gives us H1, which is I rolled a heads and a number 1. H2, I rolled a heads and a number 2. It wants us to fill in. So if I rolled heads and number 3, if I rolled heads and number 4, if I rolled heads and number 5, if I rolled heads and number 6, then it shifts over to T1. That is if I flipped tails and rolled a 1. So then we continue on. T2. If I flipped tails, rolled 2. Flip tails, rolled 3. Flip tails, rolled 4. Flip tails, rolled 5. Flip tails, rolled 6. So our total number of possibilities is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For our total number of possibilities. Just a second. Sorry about that. Okay, so it's 12. Now, the next part says, D says to flip a coin 50 times and to roll a die 50 times. I already did that, and that is what we got figured out as being what would happen if you flipped a coin and rolled a die 50 times. So these are my tally marks. Based on your data, so I'm going to do it based on this data. If you did it yourself and you got different data, that's fine. Based on your data, which compound event had the greatest experimental probability, and what was it? So I'm looking at the ones which showed up a lot. This one has a 5 plus a 2 for 7, and it doesn't look like anything else had that much. So I am going to put down E, greatest is tails 1. That's my greatest. And then least is, so look at that. That one only has 2. Everything else has at least 3. Heads 1. So, did you expect to have the same probability for every possible combination of flips and rolls? The thing is, yes, I would have, because there is a same chance. Yes, because there is the same chance of each happening. I imagine that if we did more than just the 50, if we did like 100 or 1,000 of these, that it would end up with that. I am moving on to the next part. If you want to pause, you can go ahead and do so. Okay, so when we go down to calculating the experimental probability for compound events. So it has us put together all of the possible trials of it. And then it has us adding the amount of each of them. Wait, just a sec. Sorry, it was just finding a very difficult way to say that if you made the particular choice that you were going to have 3 pieces as well as the coleslaw, you would put the number of people who chose that over how many people ordered all together and then simplify it, just like we were doing in the previous section where it was the simple one. So let's go down to number 1, your turn at the bottom. Number 1 says, drink sales for an afternoon at the school carnival are recorded in this table. What is the experimental probability that the next drink is a small cola? Okay, so we have to add all the numbers. So we have to do 77 plus 98 plus 60 plus 68 plus 45 plus 52. I am getting out my calculator. I am not doing this myself. On. Okay, so 77 plus 98 plus 60 plus 68 plus 45 plus 52 equals 400. So there was a total of 400. I want to know only small cola. Cocoa, sorry, small cocoa. So I look at what cocoa is. Cocoa is 60 out of the 400. And then I reduce it. So I'm going to get rid of the zeros because I can always get rid of the zeros. If there's a 0 on the top, the 0 on the bottom, I can just get rid of it. And then I am going to look at the 6 and the 40 and I'm going to go, what can I take out of that? Can I take anything out of that? Well, I can take out a 2 because they're both even numbers. 6 divided by 2 is 3. And 40 divided by 2 is 20. So I am left with 3/20, and that is our answer for that particular problem. Just a sec. Okay, so on the next page on 383, it's sitting here and it's talking about, once again, using a simulation. So they have the number of occurrences possible, and they have decided that they are going to go through and solve each of those ones and work it out that way. And this is what they came up with. They have the table right there with their results. So it wants to know the number of cars that are going to turn right out of 100 vehicles. We know the number of cars who are going to turn right out of 50 vehicles. And so we can just sit there and go, okay, so out of 50 vehicles, it was 6 out of 50. Now, what can I do to the 50 to make it 100? If I multiply it by 2, I get 100. Whatever I do to the bottom, I have to do to the top. So 6 times 2 is 12. I think 12 out of the 100 will be cars. Why? Because 100 is twice as much as 50. 100 is twice as much as 50. All right. I am moving on to number 3. You don't have it written down? Please screenshot it because I'm moving on. Number 3. We have a jeweler who is selling a necklace made in 3 sizes with 2 different kinds of metals. We have our data from their simulation to find the experimental probability that the next one will be a 20-inch gold necklace. And so first of all, we need to figure out how many we have. So 12 plus 22 plus 16 plus 8 plus 5 plus another 12 is equal to, and I am once again getting out my calculator, 12 plus 22 plus 16 plus 8 plus 5 plus 12 equals 75. Okay, so the 75 is going to go on the bottom. The 20-inch gold, which is 12, is going to go on the top. 12 over 75. Now, here's where it gets to be interesting, because now I need to reduce this. Just a second. Okay, so I look at this and I go, I can take a 2 out of the 12. I cannot take a 2 out of the 75. I can take a 5 out of the 75. I cannot take a 5 out of the 12. So now we have to think, what was the rule for 3? Well, if I add the numbers together and I can divide by 3, then I can divide by 3. So 1 plus 2 is 3, which means I can divide by 3. 7 plus 5 is 12. 1 plus 2 is 3. So I can divide by 3. I can take a 3 out of both of these. Divided by 3, divided by 3. 12 divided by 3 is 4. And 75 divided by 3 is, well, 3/4 makes 75, so 25. So I now have 4 over 25, and that is my probability. Down at the next section. The guided practice. A dentist has 400 male and female patients with a range of ages from 10 years to 50 years and up, as shown on the table. What is the probability the next patient will be female in an age range between 22 and 39? So we need to add everything together. 44 plus 66 plus 32 plus 53 plus 36 plus 50 plus 45 plus 74. We add that, 44. Gives me a total of 400. Okay, I now need to figure out women 22 to 39. It says it's 50. So I have 50 over 400. Once again, I have a 0 at the end. I can get rid of that. So I have 5 over 40. Well, I know I can take a 5 out of both 5 and 40. So let me just do that. 1 over 8. There we go. Can't go any lower than that. Number 2. At a car wash, customers can choose the type of wash and whether or not to use an interior vacuum. Customers are equally likely to choose each type of wash and whether to use the vacuum. Use a simulation to find the experimental probability that the next customer will purchase a deluxe wash and no interior vacuum. Describe your simulation. Okay, so what it is wanting you to do is it is wanting you to do something like flip a coin and roll a die however many times, and then what you ended up with is what it's going to be. So I think what I am going to do instead of doing that again is I think I am just going to, sorry, just a second. Sorry guys, I'm apparently experiencing technical difficulty after technical difficulty. I think I got it figured out now though. Okay, so what I am going to do instead of redoing absolutely everything, because I am not doing another one with the coin toss and the number cube, which is what they want us to do. So I can say I can simulate it with a coin toss and die 1 and 2, 3 and 4, 5 and 6 will count together. Now, remember, I used that on the previous one. Remember that one, that tally chart right there? I'm just going to use that again. I'm not making up a new one. So these ones are going to go together. 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 And I'm going to rename stuff. So instead of calling this one heads, this one is now going to be yes. And instead of calling this one tails, this one is now going to be no. And 1, 2 is going to be standard. 3, 4 is going to be deluxe. And 5, 6 is going to be superior. Okay, that's all I'm doing. I'm just reusing the results that we already had. It's perfectly fine. Okay, so what I am going to do is, it says deluxe wash, no vacuum. So I'm going down to no, deluxe, I have 5, 6, 7, 8. So I have 8. out of my 50, because I already know it is 50, I counted it when I actually did the dice in the first place. And so I look and I see, well, can I take anything out? Well, they're both even, so I can take out a 2. 8 divided by 2 is 4. And 5 divided by 2 is 25. So we're back to 4/25. Number 3, finally, how do you find the experimental probability of a compound event? Well, that's what we've been doing. You have to find how often the different events happen together. Events happen together. All right. If you have any other questions, you can feel free to leave me a message and ask for help. That's fine. Other than that, I will talk to you guys later. Bye.